Okay, let's continue from where we left the last video, in which we will talk about loading dose. Okay, so we will talk about loading dose with IV infusion and why we use loading dose. You can see this on your slide 33. Okay, for the going back to the concentration profile that we have, concentration versus time, and we have this at profile as your profile, and we said before that we have our therapeutic window with minimum effective concentration and minimum toxic concentration, and we said that this is our desired concentration, and the clinical clinical or target concentration that we are interested in for certain period of time, right? Which is the time that we are controlling to have this concentration in it. Okay, so usually or sometimes we have critical situation in where again we need to wait for this time to reach the steady state concentration, which is our desired concentration. In clinical conditions or clinical situations, I can't wait that time to reach the steady state. So we need to have a solution to go around it and to have the concentration, the desired concentration that we directly have. So the target of whatever that we will do right now is to have the steady state concentration directly. Okay, one way of doing that is taking either IV bolus as loading dose, or to take another IV infusion as loading dose, but as it's loading, it will be with fast infusion, and we will talk about it. So we will start with the first one at the beginning. Again, we will take, this is your IV infusion, which will be called maintenance now, as it's the maintenance dose, because we will have another thing that is loading as IV bolus, and again it's loading in this case, and this is concentration versus time. This is the profile of the infusion. This is the profile of the bolus. The total time, the total concentration that we will have, the target that we need to have is or will be this. Okay, this is your total concentration. Again, there is many cases for this, but this is the target that we are interested in which we will have concentration from the infusion plus the concentration from the bolus. This is as maintenance dose, and this is as, one second to fix the mic, and this is as loading dose. Okay, so this is the total concentration, and our target, as I said here, to have the steady state of the maintenance directly. Okay, so this is what we have, and to get the concentration total, I need to know the concentration of this at different time point, and I need to know the different concentration of this at different time point, right? So first of all, if we go to the, let's go with the IV bolus. Again, we know that CB at certain time equals CB naught E minus K with time. But here the time we are talking about loading, and we are talking about loading. This will be X loading over VD minus K time of loading dose. Okay, this is for IV bolus. For the IV infusion, we will have either at steady state or not steady state, right? But in general it will be, so you will substitute the right equation, but in general we will have Cb at certain time that is equal R for the maintenance, which is the infusion, over K Vt K time of the maintenance. Again, in here, in this case, we started at the same time, if you notice. So this time, which is the loading, and this time, which is the maintenance, will be the same. But if I started the bolus or the loading in earlier than the infusion, this will be different. Then according to this, Cp total at the time total will be equal to Cp of loading, which is now, I suppose, loading for the bolus plus Cp, no, infusion, which is maintenance, and you substitute accordingly. Okay, so this is what you will have, loading over Vd and you just have the total equation at certain time, and this the time that we are interested in, which is the total time. Again, just be careful if the time is the same. If we started at the same time, it will be the same. If not, the time will be different. Okay, there's another thing in your 37 slide. We have again the as profile, depending on the dose that we are taking for the IV bolus. Either we will have this as total, sorry, it's a little bit, so this is total. Let me use another one. So either we will have this as total concentration, or either we will have this at total concentration, or either we will have sorry, we had this little bit line, and either we will have this as total. And again, all of them will reach the steady state at the end for all the situations. What define the total? And again, this, and this are examples of the total concentration that you may have depending on the dose of your loading IV bolus. So we said that this is the target. We need in the target to have what? The concentration. This is what we want. This is your desired concentration. We need to have concentration of the IV bolus, which is loading. We need to have it equal to the steady state concentration of the maintenance, which is what? Infusion. This is what we are in need of. Okay, which means I need that the total concentration to be equal to the steady state concentration of the maintenance, right? I want the concentration at time 0 to be equal to this of the loading, and I want the total to be equal to the maintenance. Okay, So if we so the question will be, this will happen at which dose of the IV bolus? And this is what I'm trying to show you on your slide 37. Okay, which means that if you have this as loading over VD of loading, and we will consider that we are taking both of them at the same time, maintenance over K multiplied with VD. Okay, this is the total when this will be equal your steady state concentration. Okay, let's, which means that this equal maintenance K VD. This is the question, when this will happen, at which dose for of the IV bolus. Okay, so if you just play around with it, you will find that no RMKVD minus RMKVD multiplied to the exponent K with time, right? And this is equal minus K with time. Okay, I want this to be my answer, right? Or in other words, I need this to be my total, right? How this will happen? Just look at this and try to think about it. Okay, when, in other words, if this what I need as a final result, when this will be equal to this, right? This is my question. If you just look at that, you'll find that your loading dose should be equal to, again, this is your loading dose, sorry, okay, and see here you have VD, so we are fine. This is the difference. So you can take this out with this. If your loading dose equal the infusion rate over K, then according to this, CP total will be equal to the steady state of the maintenance, which will be equal to R maintenance over K multiplied to VD. And this is what I'm trying to show you. This is just to tell you the way that we got what the way that we got that the total concentration at certain time of both of them equals R over K multiplied to VD maintenance, and this happens under one condition: if loading dose of the IV bolus equals to R of the maintenance over K, which this is the rate of infusion, and this is elimination rate constant. Okay, so if you go to the slide that you have on slide number 38, you'll find what I told you as, again, we will talk about it versus time. This is your just the maintenance infusion. Okay, so this is the single dose of the infusion that you have. We have this as an option of total. Again, as we said, at the end you reach the steady state whatsoever. So this is the case, and it's called B on your slides. And we have another case that is, again, it's a little bit, and again you will reach the steady state. This is your C on your slide. This is called D on your slide. Again, we have in D no loading dose. Okay, and then we have A, which is higher as concentration that you need, and you will reach to the steady state. So this is called A on your slides. Okay, so according to whatever I just show you, in B, we will have it F x loading is equal R over K. You will have the steady state concentration. What we have in colors is the total concentration profile, which is with IV bolus, which I'm not showing now, equals Rm over K. Okay, sorry, this is the loading dose, but the total concentration is equal directly Rm K over Vd, which is the steady state concentration of the maintenance. Okay, and the C profile, you will have it if your loading is less than Rm over K. So the concentration that you will have will be less than the steady state concentration, okay, but it will be higher than the concentration that you have by the IV infusion by itself, which is common sense. You are giving another thing, not with the dose that you want, so it will give you a little bit higher concentration, but it will be not the desired concentration that you want. So this is C, this is B, and A, by default, according to whatever I said, the loading dose in this case will be higher than Rm over K. So the concentration that you start with, total concentration, is higher than the desired concentration, okay? Not as I want the desired concentration, but you need to just keep in mind whatever the dose that you started with, either it's the desired dose, higher or lower, we will reach the steady state at the end, which is, again, it's the which is usually 5 half-lives. You will reach the steady state whatsoever for your system. Okay, and I will stop at here. We are having, yes, I will stop it here, and we will continue in the next video.